The TRIZ 40 Inventive Principles. Genrich Altshuller, creator of the theory of inventive problem-solving, better known by its Russian acronym TRIZ, analyzed thousands of patents and identified a group of 40 techniques that inventors used successfully to solve problems across different fields. To inspire new inventors in their problem-solving, I created this video illustrating one of these principles. Principle 32. Color changes. Change the color of an object or its external environment. For example, color-changing ceiling paint. The paint is applied as a light pink color and dries white to indicate painted areas, preventing mist spots.
InSelect's color-changing ceiling paint makes it easy to coat all ceilings, from drywall and plaster to textured ceilings and acoustical tile without missing a spot. Before you start, cover furniture and flooring. Be sure to repair any cracks or damage. Stir thoroughly. Cut in the edges. Be sure to keep a wet edge while rolling in one direction. Watch it go on pink and dry smooth and white to ensure no missed spots.
Change the transparency of an object or its external environment. For example, erasable ink. The Fluorescent pen thermochromic ink becomes transparent at 65 degrees Celsius. The heat generated by the eraser renders the ink invisible.
Got the world at your fingers now, just as easy as it sounds, oh yeah. Imagine that.
Mistakes. We all make them, but don't worry. Even if it's written in ink, you can still change it. With a Pilot Friction pen, mistakes disappear like magic. But it's no trick. It's Friction's revolutionary erasable gel ink. It allows you to lift mistakes completely off the page, so there's no messy eraser crumbs or damage to the paper. Just use the specially designed erasing tip to create the friction needed to make the ink and your mistakes vanish. Pilot's Friction pens write just as well as they erase and offer an incredibly smooth writing experience. And with a new Friction clicker, it's even easier to start sharing your thoughts. So don't let a little oops ruin what you're trying to express. Erase mistakes cleanly and keep writing freely with Friction by Pilot Pen.
Oh, imagine that.
In order to improve observability of things that are difficult to see, use colored additives or luminescent elements. For example, fluorescent refrigerant dyes. A fluorescent dye is added to the refrigerant. The dye will accumulate at all leak sites. Scanning with a violet lamp makes leaks easy to spot.
There are many traditional methods for detecting leaks. Most require a lot of time and effort and aren't always 100% reliable. Fluorescent leak detection is a simple, fast, and highly effective solution that will help complete your leak detection solution routine. The process is simple. The technician injects the fluorescent dye at the low side of the unit. While the system is running, the dye starts to circulate throughout the unit. The technician then scans the system with a violet or UV lamp. The dye will be glowing at every leak site. The dye refrigerant mixture circulates and accumulates even at pinhole leak sites. When scanned with a UV light, it's easy to spot where the dye is leaking from, and the dye can remain indefinitely in the system to quickly identify any future leaks. Some of the many fluorescent leak detection benefits include universal use. It's compatible with all refrigerants and lubricants in residential and commercial systems, detecting small, multiple, and intermittent leaks, even at a distance, with the system off or running, remaining safely in systems and cutting emissions released, seamlessly implementing into a preventative maintenance program, and reducing contract service costs and callbacks. Visit Spectraline.com to see what Spectraline fluorescent leak detection dyes and kits can do for your customers and your business.
Change the emissivity properties of an object subject to radiant heating. For example, use aluminum to change food emissivity. Use aluminum foil to cover cake edges to prevent them from browning too fast.
The only thing between my head and 10,000 BTUs of radiant heat is 0.2 millimeters of aluminum foil. The sheet on my right is painted black. The one on my left is shiny. Now let's look at this on a thermal camera. My left side, as you can see, is staying nice and cool because the foil is reflecting the radiant heat away from me. My right side is getting blasted with heat. If this continues much longer, I'm gonna be like a toasted marshmallow. Radiant heat is the waves of pure energy we get from the sun, glowing charcoal briquettes, and the broiler element in your oven. Because radiant heat is infrared light, you can control it with shiny surfaces. So here's how. If you cover food on the grill with a shiny metal bowl, you can reflect the radiant heat from the coals back down on top of it, speeding cooking and browning the top and bottom at the same time. Trying to cook a whole turkey or chicken evenly? Make a foil shield for the breast and reflect radiant heat away from it. Are your cakes browning too fast at the edges? Make a foil collar around the cake pan to reflect radiant heat away. So remember that radiant heat is light, and get creative putting shiny surfaces to work in your kitchen.
Thanks for watching America's Test Kitchen. What'd you think?
Well, leave a comment and let us know which recipes you're excited to make, or you can just say hello.
You can find links to today's recipes and reviews in the video description.
And don't forget to subscribe to our channel.
See you later.
I'll see you later.
Share this video and add your examples of this inventive principle in the comments below. Color changes. Change the color of an object or its external environment. Change the transparency of an object or its external environment. In order to improve observability of things that are difficult to see, use colored additives or luminescent elements. Change the emissivity properties of an object subject to radiant heating.